one final note as we're looking at equilibrium constants for gas phase reactions is that we have written Kp with partial pressures, where we have the pressures of our products in the numerator. I keep wanting to put z there, that's a y. Pz nu z, Pa nu A, Pb nu b. Right, so this is the Kp, the pressure version of the equilibrium constant. We can choose whatever units we want for this, which will affect the values of our standard state, and we can do this in terms of concentrations instead of partial pressures. Typically in molarity, in moles per liter. Now, it's kind of weird to think about that for gases, but what we can do is define number of moles per volume that is equal to the concentration, and that's concentration in moles per liter. And so we can use the ideal gas law and say P equals nRT over V, and say, oh, well, that's right here. So, that we can say that P is equal to concentration times RT, if we want to write things in terms of molarity instead of in partial pressures. So that means that we can define a Kc, where we put everything in terms of concentrations relative to a standard concentration, and we pick C naught is equal to 1 mole per liter, a molarity of 1. All right, and so then we have our other values here. I keep writing the wrong letter there, that should be a Y. And then we have our reactants on the bottom here. Okay, and so we've now rewritten our equilibrium constant in terms of concentrations instead of pressures. And our standard state has changed from a pressure of 1 bar to a concentration of 1 mole per liter. Sometimes this can be useful. Often we'll do this in terms of partial pressures, but you can write it in terms of concentrations. And then what we would like to know, what's the relationship between Kp and Kc? Well, we can write Kp is going to be equal to Kc times RT, I should be specific here, C naught RT over P naught, raised to all their stoichiometric coefficients, like this. Okay, and that gives us a way to convert between the concentration version of the equilibrium constant and the pressure version of the equilibrium constant. We will primarily be using for pressure for gases the Kp, but we are going to, when we look at condensed phases, when we switched from just looking at gas phase to thinking about liquids and solids and solutions, we'll be making some modifications here to this as well. All right, so that was just something briefly to mention, is that we can write this in terms of a concentration version of this as well.